Graphing parabolas.
Okay. You're going to give me the function and I'll go ahead and graph it. If they give you the graph and they want you to come up with the function, then you're going to need to send me a picture of that graph.
I think it's, I don't remember, I think it's the opposite.
Do you have a specific problem?
No.
Well, let's talk about functions. Hold on a minute. Let me turn my thing on here. If we take the function, there's your parabola. That's what that looks like. Okay, this is the f of x axis. This is the x axis. So that's kind of a starting place. In other words, that is the parent function for y equal x squared. Now, did I hear you correctly that it was quadratics that you were talking about?
We were, but we're not doing that anymore.
Okay. What are you doing now?
Solving by completing the square.
Okay, give me a function.
The math teacher took all my papers, so I don't really have.
I can make one up.
Okay.
Here is a quadratic that you cannot factor. If you use factors of 5, you can never produce the middle term of plus 2x. Okay? So, here's what we can do. We can solve this. There's actually two ways to solve it. One is with the quadratic formula. The other is by completing the square. So since they've asked you to do it by completing the square, let's do it that way. And when you're solving something by completing the square, you want to get the number on the other side, like that. Okay? These quadratics are a little tricky. It depends on the technique you're going to use to solve it as to what you do for the first step. You see where line 2 is the same as line 1? Maddie, can you hear me?
Oh, yeah.
Okay. So now I have it in position to complete the square. And the way I'm going to do that is by drawing parentheses around that and completing the square inside the parentheses. Now, the technique for completing the square is the following. You just have to memorize this. You take half of the coefficient of the x term. What is that? What's half of the coefficient of the x term?
1.
And then you square it. What's that?
2.
Nope. What's 1 squared?
Oh.
It's 1. You add it to the end of that term like that. Now, because I just added 1 to the left side of the equation, what do I have to do to balance it out?
Add one outside on the other side.
to the right side, like that. In other words, when you are completing the square, you want to make sure that you do not change anything from line 1 to line 2. And I have not. In other words, the only thing I did was I moved 5 to the other side, and then I added 1 to both sides. Well, that's perfectly fine from an algebra point of view. Now, because I have completed the square, it allows me to write that as a binomial term squared. Like that. You just take x plus or minus whatever you got when you took half of that coefficient, which was 1. Add together the right two terms, you get 6. Now, from this point, how am I going to solve this equation? What's the best way to do it?
Divide both sides.
Now, when you see one side of the equation squared and the other side not, best way to proceed is take the square root of both sides. So I'm basically going to do this. I'm going to take the square root of the left side, square root of the right side. What do you get when you take the square root of the left side? When you take the square root of something that is being squared, you get something.
I don't know.
So what's the left side?
I don't know.
What's the something? What was the something being squared? X plus 1.
Oh.
So if I'm taking the square root of x plus 1 squared, what do I get?
I really don't know.
X plus 1. Maddie, the only way this is going to work is if you're able to answer some of these questions. I could just lecture at you for half an hour, but that's not going to make you learn it. What's going to make you learn it is if you are an active participant.
I just really don't know. No.
Okay, that's fine. I'm happy to tell you. And the right side is plus or minus the square root of 6. And then starting from this line right there, how do you solve for x?
Divide both sides.
You subtract 1 from both sides. In other words, I'm going to subtract 1 from that side, subtract 1 from that side. That leaves x equals minus 1 plus or minus the square root of 6. That is your answer. Okay? Let's go back and work on just solving simple equations. Something like that. In other words, math is based on a foundation that you have to be able to solve the easy math in order to do the harder math. Just have to. There's no way around. Okay? So I want to work with you a little bit on just solving simple equations. What's the first step in this equation? How do I solve this?
Right.
What you want to do is you want to end up down here, x equals something. Okay? And in order to do that, I've got to get rid of everything. I got to get rid of this plus 3, and I got to get rid of the 4. Well, in this particular case, getting rid of the 4 first is the best step. So the 4 is a divider right now, correct?
Mm-hmm.
So how do I get rid of it? You always do the opposite. Whatever that number is you're trying to get rid of. It's a divider, so what do I got to do?
Multiply.
Yeah, multiply both sides by 4. Like that. Okay? And that becomes 1. 4 over 4 is 1. So now I have x plus 3 equals, well, what's 4 times 2? 8. Okay, now I'm starting from there. How do I get rid of the 3?
Subtract it from both sides.
Yeah, in other words, that 3 is being added. Okay, so the way I get rid of it is by subtracting it. So x equals what?
8. Oh no, sorry.
8 minus 3.
5.
5. Okay. So that's a simple equation. Now I'm going to make it a little bit harder by doing this. Now what's the first step?
Getting x by itself.
Well, we're still trying to isolate that. We've got it being divided by 4, and we've got that whole thing adding 3. So what's the easiest number to get rid of first?
4. No, sorry, 3.
The 3, actually. Yeah, because what can I do?
Subtract both sides of the...
Yeah, so I'm going to subtract 3 from both sides. It crosses that out, as it always does. Leaving that and that. Now, what am I going to get rid of next? Always trying to isolate x.
So now you can get rid of the 4 by...
How do I do that?
Multiplying.
Yeah, so I multiply both sides of the equation by 4. That becomes 1. And I get x equal 28. Okay? So those are relatively simple equations. Let's notch it up a little bit. Remember, I'm trying to solve for x. So how do I get rid of x squared? In other words, how do I get rid of this 2? Square root of both sides. If you take the square root of something that is being squared, you get something. So if I take the square root of both sides, the left side gives me x. That's what I'm trying to solve for. What do I get when I take the square root of 25?
5.
Actually, plus or minus 5.
Oh, right.
And this can be a bit confusing, but just remember that if you are solving an equation by taking the square root of both sides, always begin your answer with the words plus or minus. In other words, what's x equal to?
Plus or minus 6.
Good. Now, just so I don't confuse you, that means 6. That means minus 6. So in math, when we talk about that, we are assuming the positive. If we want the negative answer, we'll write it like this. However, that is completely different then if I am taking the square root of both sides, well, I certainly get x on the left, but what do I get on the right? What do you begin your answer with? What words?
Plus or minus.
Okay. What's the square root of 49?
Oh, I know it. I'm sorry. I'm just kind of blanking.
It's good to know your squares. Okay? Let's go over and review our squares. What's 3 squared?
36.
No. 3 times 3.
Oh, 9.
What's 4 times 4?
16.
5 times 5?
25.
6 times 6?
36.
7 times 7?
49.
8 times 8?
64.
61. Oh, excuse me, my mistake. I was already ahead of myself. 9 squared?
81.
Yeah. These numbers right here end up being very important numbers to know. Just, that's the way of math. Okay? You want to know what your perfect squared numbers are. And one of the reasons is, what if they give you that? What's the square root of 162? Well, I know that that's the same as the square root of 81 times 2, correct?
Oh, yeah.
Which is the square root of 81 times the square root of 2. Well, I recognize 81 as a perfect square number. That's 9. So that simplifies to 9 root 2. And the only reason I mention that is because it was really helpful to know what my perfect square numbers are. Because whenever you're simplifying a radical, that's the key. Is you need to find a perfect square number that is a factor of that number. In other words, I needed a factor of 162 that was a perfect square number. Well, my perfect square numbers were 81, 64, 49, so forth. So I was able to find it because I knew them. You need to know them. It's something that's worth memorizing, what all of your single-digit perfect square numbers are. Hold on a moment. Solve that. Remember, we want the final answer to look like this. So I got to get rid of everything that's associated with that x squared. What's the first thing I can get rid of?
The 3.
How do I get rid of it?
Multiplying both sides.
So now I get x squared minus 4 equals 42. Now what's the next thing I want to get rid of?
The 4 by subtracting both sides.
By adding. In other words, the 4 is being subtracted right now.
Yeah, sorry, I got used to
I gotta add it.
Yeah, I was looking at something.
It's all right. And how do I get it down to x?
Squaring both sides.
Square root of both sides.
Yeah, sorry, that's what I meant.
The x is being squared right now. So to get rid of that, I take the square root.
Yeah.
And what's my answer? How do you begin the answer? With
Plus or minus.
words?
plus or minus.
Okay, that's a good start. The rest of it is square root of 46.
Okay.
Now, the question is that simplified? Can I simplify that? Well, here, let me make some room so I can continue writing. So the question is can we reduce square root of 46? Well, I know that square root of a times b equals square root of a times square root of b. So if I can factor 46 into a number that is a perfect square number, I can do it, and I can simplify this. If I can't, I don't do it. So what does 46 factor into?
Could it be 2 square of 2 and then just square of 6?
Well, you're close. Square root of 2 times square root of 23. Remember, these two numbers have to multiply to be 46.
Oh, they have to oh, sorry.
Yes. In other words, looking at square root of a times b, you can separate it into that and that. But they have to be factors of 46. And the only factors of 46, other than 1 and 46, you don't count that, is 2 and 23. Are either of these numbers perfect square numbers?
No.
No, they're not. And what that means is we're not going to do it. The simplified answer is square root of 46, plus or minus square root of 46. Now, let's just say it was the square root of 48. Can you split up 48? By that I mean, can you factor it so that one of the factors is a perfect square number? Think of factoring 48. Let's go over here and talk about factoring numbers. We know that two factors are 48 and 1, correct?
Yeah.
How do I find a second set of factors?
Go to 2 and 24.
Yeah. In other words, if I can cut 48 in half and double the other one, 2 times 24 is certainly 48. Can I do that same process again? Can I cut 24 in half?
Yeah. 3 and 12.
Which means I got to double 2. Can I do it again? Can I
Yeah.
cut 12 in half?
Yeah.
Got a double 4? Can I do it again?
Yeah.
Can I do it again?
No.
No, I can't. In other words, I think I have found all of the factors of 48. Now, which ones have perfect squares in them? Starting from the top. Well, that one does not.
No.
That one does not. Neither 24 nor 2 is a perfect square number. How about this one? 12 and 4.
Yeah.
Yeah, that works. How about 6 and 8?
Yes.
No, neither 6 nor 8 is a perfect square number.
Yeah.
How about 3 and 16?
No.
16 is a perfect square number. 16 is 4 squared.
I thought they both had to be.
No, just one of them. As long as one of them is a perfect square number. Now, the secret is to find the largest one. Well, 16 is bigger than 4, so I'm going to use that one there. So I'm going to split this square root of 48 up into square root of 16 times square root of 3. And the reason I want perfect square numbers is because that turns into a whole number. That turns into 4. So the square root of 48 is the same as 4 times the square root of 3. And I did it in one step. That's the advantage of finding the biggest perfect square factor. I could have actually made progress using that. Let me show you how. Square root of 48 equals square root of 4 times square root of 12, which equals 2 square root of 12. You with me?
Yeah.
Which equals 2 square root of 4 times square root of 3. Well, square root of 4 is 2, so that equals 4 square root of 3. Same answer we got first time. How many steps did the first one take? 1. How many steps did the second method take me? 3. The point being that if you're going to try to factor this number 48, to simplify it, you want the largest perfect square number. 16 is larger than 4. They are both perfect square numbers. But you always want to use the largest. You can get to the answer using the smaller one. Definitely can. It just takes more steps. Let me see if this straightens that out. All right. So let's get back to quadratics. That's where you're at, right? In quadratics?
I mean, I think so. We
Well,
move so fast that I feel.
algebra is an extremely broad subject.
Yeah.
I want to talk about what you're doing in class right now. So I need you to tell me that. Might not be quadratics. I don't want to talk about quadratics if you're not doing them in class.
We don't really do anything in classes. Is like the tough part, unfortunately. That's kind of why I'm so lost.
What kind of tests you're taking? What kind of problems are on the tests you're taking right now?
So we had a quiz last week, and not last week, before Thanksgiving. It was like on parabolas and stuff.
Parabolas or quadratics? In other words, this is a parabola right here. This is what the graph looks like. That graph is called a parabola.
Well, we had both on there.
I'm sorry, what?
We had some problems with parabolas, and we had some with quadratics.
Well, they're both quadratics. In other words, if I were to write this, that graph is like that. They're both quadratics. It's just they graph a little differently. And if I were to graph this, it would look like this. All quadratics graph as parabolas. That's a parabola, that's a parabola, that's a parabola.
Yeah, that was definitely on the list.
Sometimes parabolas look like that. They're upside down. But they're going to look either right side up or upside down. That's it.
Yeah.
Okay. And quadratics are actually a really big subject in Algebra 2. You probably spend 2 or 3 months on quadratics alone. There are so many different things to do with quadratic. You can solve it for the zeros, you can graph it, you can solve for x. There's just a ton of things. So I really don't know where to start with you on quadratics.
The thing, like what you're just doing.
Well, it would be a lot more helpful if you could give me a specific problem that they've asked you to do that you don't know how to do. Because, like I said, quadratics are a 2 or a 3 month subject. So I really don't know where you're at in it. I need your help in telling me that. I'm quite certain I can help you, but I need a starting point.
Yeah, sorry. I had to turn all my papers in with all the.
Okay.
Usually I have stuff.
Well, I tell you what. Let's talk about factoring. Because most everybody, you can't get anywhere in algebra without knowing how to factor. Did we do this last week?
Yeah, we did factoring last week.
Well, let's see how well you remember it. Factor that.
Do you want me to just write it down and then tell you the answer? Or do you want me to...
I want you to think it through just by looking at my page only.
Okay.
And tell me how you would factor that.
So find the greatest common factor.
There is none here. That is the first step. Very good, because a lot of expressions you will find a greatest common factor. If you can, that is definitely the first thing you should do. But notice there's no greatest common factor here. There's no number I can factor out, and there's no variable I can factor.
Yeah.
So when you see a quadratic like this, the only way to factor it is really a binomial times a binomial. And the steps are really quite straightforward. You separate the x's, like that. You determine the sign. What are both signs?
Well, negative.
Nope. If they were both negative, that would be a positive 10.
So is the first one negative and this? No, they're both positive.
No, if they were both positive, that would still be a positive 10.
Is the first one negative and the second one positive?
They're opposite. And it's either way. I can make the first one positive and the second one negative, or vice versa. It doesn't matter. They're just opposite. That's what you know.
Okay, yeah.
And now the third rule is looking for factors of 10 that subtract to the number 3. What would those factors be? Factors of 10 that subtract, because of that negative sign right there.
2 and 5.
Yeah. Take the bigger factor, put it with the sign of the middle term. Where's the 5 go? Take the bigger factor. You know the factors are 5 and 2.
So it's in the first one?
Yeah, the 5 goes with the negative sign. The 2 goes over there. And if you FOIL those back together, you will get what you started with. Always remember that that's all factoring is it's the reverse of FOILing. When you FOIL, you do the first times the first. You do first times the second, that's the outside. You do the second times the first, that's the inside. You do the second times the last, that's the last. That's what FOIL means. First, outside, inside, and last. Well, notice the last is what produces this number. So if you're doing it in reverse, the sign on that constant is super critical. That's what tells you that the signs of the factors have to be opposite. Because that's the only way you can produce a minus 10. All right, Maddie, the text you sent me said you only wanted to do a half hour tonight? Is that right?
Yeah, I'm like swamped right now. I have like reports and
That's
projects,
fine. That's fine. We can stop now. Um,
but I thought we
let
might be doing.
me first of all check my calendar because there was a bit of confusion. I have you down next for Thursday at 5:30.
Yeah, I have a test on Friday. So.
Okay, so we're going to do an hour Thursday at 5:30.
Yeah,
If you could bring me review material, that would be super helpful.
yeah, we're getting. Yeah, tomorrow we have a review packet we're getting. So I
Okay,
will.
and if you can verbalize it, that'll be fine. If you can't, take a picture of it, send it to my email address.
I should be able to just be. I
Most
could send
most
either way.
algebra can be verbalized. The only algebra problems that present a difficulty in verbalizing are when they give you a graph and they say come up with the function for that graph.
I have a. I'm gonna guess that there might be one or two problems like that, so I might just send it over for
That's
those.
that's fine. Make sure you have my email address. The best place to send any material that you want to cover is, hold on, I will write it because you may not have it. It's my name, David Cowan, 1949 at gmail.com. Anything you want to send me, send it in advance to that email address. And then what
Okay.
I'll be able to do is bring that picture up on the screen. We'll both be looking at it. So if they give you a graph, and they want the function for that graph, be a piece of cake. If
Okay.
they give you the function and they want you to graph it, you don't really need to send that to me. You can verbalize.
Okay.
So most algebra can be verbalized. But
Yeah.
if they give you stuff that cannot be verbalized or if it's a long, complicated word problem or something, just take a picture of it and send it to my email address.
Okay. Yeah.
Okay? Maddie, you have a good rest of your week, and I'm going to talk to you on Thursday.
Yeah.
All right. Bye bye.
Thank you.
You're welcome.